Hello, everybody. This is a new data set I want to work with. So this data set is called home runs. So a little bit information about this data set. As you know, we've shown the visualization for trend curves based on the data set for the vehicles which we used before. So we use the MPG data. But now we want to work on a new data set. So among the common questions or common problems data analysts usually have is how can certain variables change over time? How can you have a variable and the variable will change over time? So when the data set contains any kind of time variable, such as year, hour, quarter, month, and weeks. So we refer to this data, this kind of data as time series data. So the time series data have a very different ways of analyzing them. So one of the good ways to do this is with a line graph. You don't have to use a point, you don't have to use a dot. So this data, which you see being uploaded, is gives a home run total in Major League Baseball by league every year from 1973 to around 1995, if I'm not mistaken. So it's around till 1995. You cannot see all the data here, but if you check here, it's going to be there. So to 1995. So then we want to analyze this data. We want to analyze this data. So, and we want to see how the data, how they differ, what is unique about them, and all the stuff. So this data is actually not in the not embedded in the it's not been embedded in the in our packages. So this is why we decided to load it directly into the website. So we got this from the GitHub repository of someone, and we decided to put it here. So, but it doesn't matter. Anyhow, we can even get some from the web. We can web scrape some data. Anyhow, we just make sure the data is accurate. So once you load the data, maybe from people's computer, maybe from people's website, once you load the data and the data is fine, you can work with it in a fine way. So let me do a quick analysis with this data. Let's do the ggplot, the same thing we did before. So ggplot, then data. What's the name of the data? Remember, the name is not MPG anymore. It's not home runs. So as you can see now, it's being brought up. So this is the first thing you do. Since you want to write more things, so you say plus, then you move on more to the next line. So it's been indented. So we want to use a geom line now because we want to draw a line graph. Remember when we drew a when we drew a point graph, we use a geom point. When we did a smooth, which is the trend curve, we use a geom smooth. And now we want to use a geom line because we're doing a line graph. So this is what they mean. So then the next thing is mapping. So when you're mapping, is going to be aesthetic. So yes. So what is that going to be? Open a parenthesis for it. So your X, you want your X to be the year. Excuse me. And you want your Y to be the home run total. As you can see, the home underscore runs underscore total. Underscore total is been so this is it here. So you want to compare the year and the runs total. So this is a league is a character. So then you run this command enter. So there is a little problem. So isn't there's a problem occurred there? So let's go through quickly and see what the problem is. So Says Geomline problem computer statistic. So there's a problem with the mapping and the AES. So where could the problem come from? X is equals to year and Y is equals to runs. Okay, I think here is a problem. It's run, not runs. So now we have it. So we have the data now being visualized here. So take a look at this visualization. So it shows you the home run total and the year. So as you can see, here is a movement. So it doesn't look right. It actually look very rough. If you look carefully, you would notice that there is a vertical line segment above each year, so which is not supposed to be, because this is because the year in the data set is entered twice. So you have 1977. So it's gonna be, for example, 1977, when you have it two times, it's gonna be a bit, it's not gonna be very accurate. So this is why. So it's been so once for each league. So we've got two leagues. So one for NL and one for AL. So it will be better to separate the line graphs for each of the leagues. So we can use the league as a factor to separate it. So instead of putting the data together, we can separate it. So how do we do this? I'll copy this because I usually like it when I rewrite the code. So I will write a comment here. So I will say we want to separate line graph. We want to separate the graph by the league. Separate the graph by league. So you want to separate it by the league. Now, how do we do that? So you put the same code. So when you're going to make a difference is the color. So you click here. So you say color is equals to league. So you want to separate it with the league. So now it's going to give you two graphs. Let's run it and see. It's going to give you two graphs now. You see. So now you've got two graphs being separated by the league. So now you can see it looks pretty better than what we had before. So you've got AL is the red and NL is a blue one. So this is something amazing about using R for data analysis. So it's often helpful to overlay a scatter plot. So if you want to, it gives you more information if you put a scatter plot on top of this line graph. So that will give you some hints about this graph. So we can also move the mapping argument up the ggplot so we can have like what we did before. So we can have all of these, all of the information in the ggplot area. So we're gonna do the geomline and geom. You know, we did two things the other time. So you can copy this. Since it's the same, it's the same thing you want to do. So you're gonna remove this. You're gonna remove this and put a comma and then you bring it down. So, or you can, so yeah, you're gonna write geom, you're gonna write geom point, you're gonna write geom underscore point. So then you open the parentheses and everything you had before, you put it here. So we're gonna have a little problem here because now we open it and now you have 1, 2, 3, 1, 2, should be 1 here. So there's the problem here. So we should cover this. Yeah, we should cover this. So I think it's fine now. So if you cover that, we should also cover what here. So there should be two. So we've got 1 here, we've got 1 here. So that's fine. So and this has got 1, 2, 3. So it should be 1, 2, 3. Nice. Okay. So if you run this, we would see there's the problem. It's a problem. Let's see here. So we have 1, 2, 3. Okay. Go 1, 2. You have 2. This is 2. So, but I think, okay. I think instead of putting that, we should just put a plus. Yeah, because it's not the same thing. Yeah. Instead of putting that, we should put a plus because we continue, it's a continuation of it. So it's still talking about something else. So it says it's asking, but instead of doing this, we can make it in a simple way. So now we don't have to waste time. So we can decide to use the data home runs, and we can put all of this in the, you can put all of this, you can put all of this here. So just put a comma and put all of this. So also put that, just remove this, because the main thing is, since we are having since we're gonna have the same thing, so just put it that way and put plus and then write a geom point, then geom underscore point. So, but sometimes you might also have a problem if you are not careful. So let's see, let's run through the data, through the codes, ggplot data with custom home runs, then command mapping is that X is here, Y is home run total, then you've got color to be the league. So then how many do we have? Okay, we have 1 missing. We have 1 parenthesis missing. And once we fix that, it should be fine. Then let's run it and see if we're gonna have what we expect to have. Now we have it. So this method is pretty easy. For me, it's pretty easy. You can as well do it the way you saw me wanting to do it. But we sometimes when it's too many parentheses, it becomes a problem. So you can get confused. So now you would say now there is a dot on every what do you call it, joint of the graph. So this gives you more visualization of the dots of the information. So now you can see dots here. So if you trace it down, it's around 1976 or 77. So, and the home run total was around above 1,000 a little bit. So you can use that dot to easily analyze or easily visualize the data. So a line graph are nice, and of course we all agree, for time series analysis because the lines that actually join the successful points make it easier to visualize it. So this is exactly what we decided to do here. So we can also use what we call the box plot. We also use what we call box plots. Box plot is one of the plots which is very common in R. So, and we can use the same data we used before, which is MPG for the box plot. Let's write a code ggplot data equals to MPG. And because MPG data will be pretty good for this because it's going to be a box plot. So then we want to use a geom plot, geom underscore plot. So then we do the mapping. So the mapping is equals to AES aesthetic. So we use X to be the DRV and we use the Y. I think you still remember that we had the data called MPG and we use the Y as the ish highway HWY. So the highway fuel consumption or fuel preservation. So when you run it, I could not find geom plot. I could not find the function geom plot. Yeah, I think I'm still making the same mistake. Geom point. It's not plot, geom point. Yeah, so you run it. Now you've got the geom. This is called the box plot. So this the point of this exercise was to show that the scatter plot are not right visualization. So because what exactly can you say about this? So I can just say the highway conservation of DRV is more than R18. It's yani it's when the either of the variables are categorized. So a much better option is a box plot. So this is a dot plot. So it did not actually give you anything very very meaningful. So this is why the best thing is for you to use a box plot. But before we use a box plot, we need to understand that a box plot we actually defines a median. So a median of a continuous variable is a number in the middle position. So when you pull the numbers in numerical order, the one in the middle position is a median. So if there are an odd number of a point or the average of two middle numbers, if there are an even number point. So if you have an odd number, the middle number. If you have, let's say for example, you have a data set that is got 20 20 things, 20 values in the data set. So you cannot have a middle value, you just have to sum up two middle values and divide it by 2. So this is how we do it. So, and also, if you have an ordered continuous variable, the first quartile, we use something as Q1, like the median. So the first quartile is, we can use the smallest is 25%, and the largest is 75%. So the third quartile is 75%, and the first quartile is 25%. So, and the data between the Q1 and the Q3 will be the 50%. So that would be the median, which is also known as interquartile. We're going to talk about that later in full detail. So that is called the interquartile. So now let's do an example of a box plot and let's see the difference. So we do the same ggplot, then we do the data. We will not be messing around too much because we have a target. We're actually working towards how to analyze data using R. It's not that we're teaching the whole of R. So then you got box plot. So this is how we do it, Joom_box plot. So you put the same details as you did before. Mapping is equals to AES. AES. So in AES, you declare your X. So what do you want your X value to be? You want your X to be the RV, and you want your Y to be what? To be HYW. So then you want this. So now you can see, so this is makes more sense now. As you can see where the median is, so you can easily see where the median is. So for each of these possible values here, for D, R, for F, and R, we get a diagram interpreted as 1. The horizontal line inside this box here, so is drawn at the median value of HYW. So for a given value of DRV. So the top horizontal line is drawn at the third quartile. So the third one is drawn at the third quartile, and the bottom one is drawn at the first quartile. So this is the third quartile, the one here, and this is the first quartile. So what is the median? The middle one is the median quartile. So this is the interquartile, which is the median. So the length of the vertical line above, respective below, the box is a smaller 1.5 times QR, like interquartile. And the distance from the maximum data point to Q3 respectively is a minimum data point. So the mean is the medium is this, and the highest is the one on the top. So the dots above, what about this dot here? Well, this doesn't have dot, but it's got dot above and below. So what do? They represent the data points that are greater than the Q3 plus 1.5 times IQ3 and less than Q1 minus 1.5 just IQ3. What does that mean? We're going to talk about that later when we talk about statistics. So the point is, the summary is, cars with a front wheel drive tend to get best highway gas mileage. So you will see the best gas mileage. So the cars with the front wheel drive, they tend to have the best highway gas mileage. But also, there is a lot of variation among the values of the HYW in that group, especially beyond the interquartile range. So cars with a rear wheel drive have a larger interquartile range. So they have a larger interquartile range. So the ones with the rear wheel, which is the R. So you can see the space is so much between them. So, but the value of the HY do not stay very far outside they don't actually have big range like it's found in DRV. So the full wheel, which is this, the driver has a median value that is much closer to the Q1. Can you see? So the median is very close to the Q1 than the Q3. It's far away from the Q3. So what does that suggest? So that tells you that the value of the HWY, which is the highway fuel conservation or consumption, above the median is significantly farther than the median than those below it. So the ones above the median is far away. The ones which is in the Q1 is far away from the median value. So this is we can easily interpret this compared to the other one. If you run this, you cannot interpret anything. It's very, very difficult. So this is why we don't usually want people to use this in data analysis. So we prefer that people would use this, the second box plot. So, and it's often very helpful to produce box plot in which the boxes are displayed in ascending or descending order. So you can use that if you want to. Sometimes people usually give this kind of visualization, but we usually encourage that it's fine to make sure that they are in ascending or descending order based on the order of the height. For example, this is the highest. Should it be in the beginning or should it be at the end? The one in the middle should be the next. So instead of having it separate like this. So for the box plot above, it will mean switching the word boxes R and F. So we can do that automatically. So what you would need to do is just manipulate the code a little bit. I'll show you now. So just copy this. Now we want to, so let's do, we want to arrange the box plot, arrange the box plots in ascending or descending order. So this is going to give anyone who wants to view the data, view the visualization. It's going to give that person a very good image of who you are. So what do you need to do? Just pull mapping AES X. So you're going to say X, you would have to pull reorder. Say reorder. So reorder is a keyword that is going to change the order of the drive, then HWY. So it's going to reorder it. So it's going to reorder the two, compare the two and put in order, either ascending or descending order. So after we do that, everything should be better now. Let's start to run it. So now you say, so this, which is the highest, is pull, that means is arranged in ascending order. So starting from the least, the one after, and so now anyone who sees this data can easily know that, oh, and so we've got the highest value with the front wheel. So another way we have with the box plot is to flip them to the boxes could be horizontal. Instead of standing vertically, we can make the boxes to be horizontally arranged. Why do we need to do this? Is helpful when the categorical variable has a lot of values crowded together onto the x-axis. So what do we do? The only thing to add to it is, let me write it, flip the box plot horizontally. So this, I usually like to do these a lot because it gives me the mindset of what I did and why the code were written again. So it's a very good way. If you can learn to do it, it's fine. And if you feel you're comfortable without writing it, it's fine. It's not a problem. So what do you do after you've written this? Then you write plus because you want to continue with your code. So you write plus and you move on to the next line, and you would write cohort. So what does that mean? The meaning is chord flip. You want to flip the coordinates. So that's the meaning. So chord means coordinate. You want to flip the X and the Y coordinate. So once your R receives the order, it's gonna do it. So it wants to flip you want to flip it, so it's a coordinate flip. So let's see if there is a problem because I'm having. So it says unexpected end of document. What does that mean here? So mix over a plus, so that's not a problem. Okay, here, I think it's here. We're not supposed to pull this here. ggplot data equals to mpg, and gem box plot mapping equals AES X reorder dr h y and y is equals to h wy. So then plus chord flip. I think everything is fine. It's no problem. So now we got it flipped. So in this case, you can easily see. So the box plots come with various aesthetics. So it comes with various aesthetics, which we can there are good ways to visualize how a continuous variable depend on a categorical one. So these are very important things we need to understand when you're trying to visualize the data. So all of these things are very important things. So now the next one we want to talk about is the bar graph. So let's see how to view bar graph. Bar graph and histograms. The bar graph and histograms, they really look alike, histograms. So the visualization we've seen before now, the scatter plot, the trend curves, line graph, box plots, the ways to display covariation when they go so the covariate. So when there's covariation among two or more variables, so this means that they show how changes in one variable are related to the changes in another variable. So this is what we call covariation. So the meaning is when we have two things that vary together. So when you use scatter plot, trend, line, box plot, we display covariation among two or more variables. So the meaning is we can actually see the changes in one variable, how it relates to the changes in the second variable. So, but if you want to use a bar graph, is a way to visualize how how values of a single variable vary. So you try and look at a variable and see how the values in that single variable, how they differ from each other. So the two primary visualization that accomplish this bar graph, or sometimes we use histograms. So we call that for categorical variable. So, or we call histogram for continuous variable. So when there's categorical variable, we use a bar graph. When there is a continuous variable, we use a histogram. So both the bar graph and histograms, they visualize how a single variable is being distributed by providing a count of how many times its value of the variable is attained. So let's start with the bar graph and we will see what I'm talking about here. So now we're going to say there is a data set which is embedded in ggplot, which is called Diamond. So we call ggplot and we use the data equals to Diamond. So Diamond. So then we would see we would use a geo underscore bar because it's a bar graph we want to draw. So then mapping. So by now we should have got used to this way. Mapping equals to AES. Then we put X equals to pot. So, and if you want to visualize the data set before doing anything, you can also visualize it you can do the, if you want to know, have more information about it, so you can do this, diamonds. So you run it. So going to give you some information about it. So this is a data set that shows the prices of over so the data set contains the prices of and all the attributes of almost 54,000 diamonds. So the variable are follows the usage, the format, a data frame of 53,940 and 10 variables. So the price 0.2 to 5.0. The cut is a cut, fair, good, very good, premium, ideal, color, clarity, X, the length in millimeters, Y, the width, the Z, the depth, the table. So all of these are the variables you have. If you want to see the diamond data, you can say diamonds. So we use a view keyword to view the data, view diamonds. Let's see if it's gonna work here. So let's run it. It's not there. View diamond. Okay. So this is the diamond data. So as you can see, this is a carat for the data set. It's a lot of data. As it's mentioned to you, you cannot see all of it. Something which is almost 54,000. So you don't need to bother yourself much. So just for you to have a look at the table, some of the things in the table. So this is it. So it starts with the carat, the cut, the color, clarity is a depth, table, price, X. The X is the length in millimeters, then Y is the width, and this is the depth. So these are the information about the data set. So as we can see, the diamond is an ideal, let's take a look at the visualization again, and let's see what we have. So we can see the one with the highest count is ideal. So the ideal cut, they are most numerous in the data set. Sometimes it's preferable to have a bar graph show the percentages that each category makes up in the data set. So in that case, we can think about a bar graph as representing a probability distribution of the different categories. So we can override the mapping of count to Y. So let's see how we can manipulate the codes. So let's just copy this. Let's copy this. So we want to so we can just say, so paste it, and I just want to so we want to say we want to show the percentage, show percentage of each category. So now you're gonna know why you want to write some other codes. It's very good. So what do? We write ggplot diamonds, still correct. Geom bar mapping, ES, so X is cut, and we want to make Y is equal to stats. So we want to start. Well, it's a problem. So start prop. So then we want to group. We want group equals to 1. Well, all of them in one group. Okay. So let's run it and see. So now we still have almost similar. So the group 1 mapping is included to make sure that the proportions, we put group 1 to make sure that the proportions calculated by stats prop are relative to the entire data set. So we want to make all the data set 1. So not just relative to each category, not that we want to have separate category. This is not what we want. So this is exactly what. So can we can also remove the one and see what happens. So let's remove this one and see what is going to happen. I think it's going to be almost can say. So now it's going to do it separately. So this is something we need to be very careful of, because you pull the Y stats and it's going to think is supposed to do for each of these data set differently, but that's not what you're aiming at. You want to have all of it to be done as one group. So this is why you need to pull this. So if you pull this and run it again, so it fix the data properly for you. So, and from what we see in the data, from the above bar, we can read off like we can choose a category which is having more. So like the very good is got around 0.2, that is around above 20%, and the ideal is got something around 40%. So this is it. So we can look at how we can use the same data set for histograms. So we want to see how we can use the same data set for histograms. And so how do we do with the histograms? So histograms, they serve almost the same purpose as bar graph, like I mentioned to you before, but they are used for continuous data that increases. That is a continuous data, I mean, not the one which is for categorical, like the bar graph. When you are having different categories, it's a different thing than having a continuous data. So we solved the problem by visualizing a continuous distribution by binning, something called bin. So binning is a process of subdividing the continuous interval of values. Since it's a continuous data, we would not want to visualize all the data set at the same time. So what do? We put binning. So this binning, what does it do? It helps to cut the data set into different bins. So what would it would say it's going to stretch from the minimum value to the maximum into subintervals or bins. So each bin is then treated as a category, and a count of a number of values in each bin is made up and being used to determine the height of the bar. So I will show you what we mean now. So let's say, for example, we want to draw an histogram. So we will use the same ggplot. So you call the ggplot, and we want to use the same data set, which is a diamond data set. Diamond. It's already here. So since you want to write more things, you put a plus. So you go down, it dents automatically. So now we're going to call Geom histogram. So Geom histogram. So in it, we have a mapping. The mapping is equals to aesthetic. And what do we want to view? We want to view X equals price. We want to view the prices, how the prices differ. So now you can see what is showing there. So you can actually override the default number of bins by either specifying how many bins you want or specify how wide you want the bins to be like. Because now it's just a continuous, as you can see, it's not showing any real, it's not showing something very, very interesting. So you can decide to, I just want to make this very explanatory. Add bins. So how do you add bins? So you would say the same, let's copy this, the same block of codes, and you would add after the price, you add bins. So you want to make the bin to be 50, for example. Let's make it 50 and see what happens. So the meaning is you're subdividing it, you're breaking it down into bits. You don't want to have all of it at the same time. So this is why we're using the bin. So it's still we saw the data the way it looks, but it still did not make much difference compared to what we had before. So what do we do again? Then we would want to use a bin so we decline the bin with instead of only bin. So let's do another one. Let me declare bin with. So then you're gonna paste the data you have, paste the code you have. So instead of bin, you said bin width. So the bin width, you wanna make it, for example, let's make it 1,500. So that's a way to subdivide it. So now it looks pretty better. So now you can, so choosing the number of bins in an Instagram is a sub to heart. It's a very easy, is a solution to many problems. So you don't want them to be so wide that they make the distribution look very too coarse, very horrible. So you don't want them to be so narrow too that you cannot even see anything. So that is why you have to determine what exactly you want it to look like. So this is exactly what we're gonna have today. So hopefully we will be moving on to another section of the data analysis skill using R in the next video. Thank you very much for listening, everybody. Have a nice evening.